All right, so yesterday I hope that you took advantage of the two quizzes that I tried to set you up for. I hope that you used all your time wisely enough to get your grade to go up. Those may not be in right now, but hopefully, like I said, if you did do what you needed to do, then your grade will go up because when those grades go in, they will average out. Now keep in mind, if you happen to get, let's say, 4 out of 10 on the first test and a 10 out of 10 on the second test, don't expect a 100 to show up because that is a average of 7, which means that the final grade that goes in is the average of the two. If you want that 100 to go in, if you got a high score yesterday, is you have to take it one more time and cancel that lower score out with another high score. So keep that in mind. Some of you might have to take it 3 times to get your grade where you want, but other than that, just remember, again, you are down now to a little bit over 2 weeks to get your deadline, so I hope that you are doing what you need to do to get this job done, because again, I cannot force a grade on you. I can't force you to fail. I can't force you to pass. It's up to you. Other than that, tomorrow's assessment is quick. It's over a topic that you're either going to care about today and do what you need to do, or not care about, and you know what happens after that. Scatter plot is exactly what the root word indicates. The word scatter and plot, it is a plot of scattered points based on a set of data. Typically, whenever real life kicks in, the numbers are not always lined up perfectly, and so in order to ensure your points are accurate, you need to make sure that you approximate. So what this allows you to do is, let's say you have something talking about gene cells where average price is here and the number sold. So if there is a certain price of genes, maybe the price affects the number of genes sold, as it probably would happen. The cheaper the price of genes, the more that will sell. As the price of genes go up, it probably sales go down. But again, that's what the scatter plot will tell you. In order to do a scatter plot, what you must remember is that this is your independent variable. So average price goes here, and this is number sold here. Now you need to make sure you have room for everything. So notice that the highest number is 40. So what I'm going to do is count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. You don't need to label all of them, but again, if you're making one, just making a label that actually allows them to follow is good. Notice the highest number here is 130, so I'm going to count by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30. Again, this is a pretty much it's just an image to give us an idea for what's going on. So again, your numbers don't need to be perfectly lined up, but you just need to make sure that you have it set up at least mostly consistently to see what's going on. And again, all you have to do is match the numbers. $21 price led to 130. So again, where the approximation comes in, this is about 20. A little bit further than 20 goes up to 130, which would put the dot somewhere around here. $28 sales, which would be between 25 and 20 or 30, 25, it'd be right in the middle, leads to 112. Well, 112 would be a little bit over 110. So again, taking this number here up to about where 112 would be would give me an idea about that. $36 price led to $82 or 82 genes being sold. So again, 36 is just past 35, and 82 is going to be just over that 80 number, somewhere around here. And then $40 genes led to 65 of them being sold, so that's going to be between 65 and 70. And what you can call this is a negative correlation. Again, the correlation between the two things is negative because notice that the slope of those dots is going down. And again, that's all a scatter plot is. Now this is not a line, and even if it is close to a line, it doesn't have to be. You see some scatter plots that look something like this, but again, that's still a negative correlation because as you look at the general dots, they go down. Alright, so again, your scatter plot itself is one thing it's going to ask you to do. You'll see that on your work today, and all you have to do for your scatter plot is be able to tell which one matches the data. So you have to take a piece of paper, plot it kind of like I did there, and then pick the one that best matches what you have. You have movie tickets sold by year. Again, you're talking about your scatter plot. Notice that these are big numbers, 1998 to 2007. So what I'm going to do is just put it in, let's see, 98 to 2007. That's about a 20-year span. So I'm going to go by, let's see, 97. Let's say 98, 2000. Actually, it doesn't matter because I think I got enough time. 98, 2000, 2002, 2004, 2006, 2000. Actually, I can probably go 98, 99, 2000. 1, 2, 3, 4, 5, 6, 7. So again, based off of that, I don't always need to start at 0, but it does help. But again, make sure you have it marked so you understand what you're counting by. Otherwise, what happens is you get caught up on not knowing where your dots belong. And then your numbers here go from 1200 up to about 1500. So I'm going to start at 1000, 1100, 1200, 1300, 1400, 1500. So 1000, 1100, 1200, 1300, 1400, and again 1500 right there. And again, all you have to do is approximate. 1998 says it has 1289, so this would be 98. That's 1000. That's 12,000 or 1289 to be closer to the $1300 range. So a dot would go about there. 1999 was 1311, so 1999, 1311 would be slightly higher than 1300. 2000 would be about 1340, so that's going to be just below about 1350 range. 2001 was 1339, which is actually lower. It should be a little bit lower than that first dot there. 2002 was 1406. Again, that's just right at about that 1400 range. 2003 is 1421, which is slightly higher than that, but again, not a lot based off of that. 2004 is 1470, which is higher than that. 2005 is 1415, which again is lower. It's going to be down here somewhere. 2006 is 1472, which is again higher than that. And then 2007 is 1470, which is again right around that range. Now you could say this has a positive trend, but you notice at the end it kind of flattens out. But again, it does have a more of a positive trend going on than anything else. But the key thing I want you to notice is, first off, we have to label our parts there. So year and tickets. But I just want you to notice again that the dots are not in a straight line. That's why it's called a scatter plot. Alright? Because scatter plots are so random, it is important that we try to use the values to determine where the values should be. So again, what you call that is a trend line, or a line of best fit. Since the points are scattered so much, we need to use a calculator, because again, there's no human way for us to know exactly where the parts are. But the calculator, what it does is it's able to look at the points, take all the points into account, and figure out the best possible approximation of where everything should be. So again, what the calculator is going to do is it's going to help us create a function, kind of like you did in chapter 4. And then in your calculator, again, we call that linear regression. Be sure again to take notes on this part of the assignment, because tomorrow you have to know how to do this, and it's going to be based off of your understanding. You do not need to write the descriptions under here, because you should have at least something to help you. But here's what you have to do. First off, you're going to press the stat button. The stat button I'll show you in a second. But what the stat button does is kind of like the math button. It brings up a menu of things that allows us to edit a list of points. When stat comes up, you have a menu, of course. You're going to see the word edit. That's going to bring up a table that we're going to enter the values of the scatter plot into. You're going to enter the values. L1, as you'll see, represents your X values. LT is going to represent your Y values. Once you get your values in there, you're going to press stat again. Again, it's going to bring up a menu of things you need. You're going to see that there is a area called calc, which is for calculate. And again, that's what you're going to use for your linear regression. And after you hit that button, you're going to choose linear regression AX plus B. Now I want you to think about the fact that the formulas that we have look like this, and that is because A actually represents your slope, and B, whenever they give it to you, actually represents your y-intercept, and that is where you're going to get your function for your final answer of the problem. Again, I hope you rewind this, take those key notes down. It's only really 6 steps, but the key thing is tomorrow, if you come up to me and ask me how to do it, I cannot help you. Now, if you come up today 15 times, that's fine. I can help you as much as you want. But if you do not get help on it today, if you do not take it seriously enough to understand it today, I cannot help you. So take your notes. Make sure you read your notes. Make sure you get a lot of practice today. And again, make sure you know what's going on. After you go through that process, again, you're going to be given a value for A and B. Those values are going to be used to create the function that we need. So let's just go ahead and get right to it. Look at some examples. Again, make sure you work through this example so you get some practice doing it, because you have to be skilled at this process by tomorrow. If you run into any issues, please come and see me immediately. because it is very important. So this says find the equation for the line of best fit. Again, that's the anticipated line. Then use it to determine how many tickets to be sold in 2015. So again, the first thing we do is you hit stat. So stat brings up that part I was talking about, and we want to edit the list. So you can either hit 1 or you can select edit, which is already there. Notice on here you have L1 and L2. Now if you have numbers in your chart already, here's what you do. You go to memory, which is right above the plus, MEM. You hit second memory. Alright, second memory brings up the key part about here. 7 has reset, so choose 7. You want to choose all the RAM, which is your memory parts there, so choose 1. And then this gives you the option to say, do you really want to reset it? Of course your answer is yes, so 2 goes there. And again, RAM is cleared, and you should notice when you hit stat and edit again, that it is clear. I'm pretty sure that should have worked, but like I said, mine was already clear. Other than that, what I told you was that L1 represents your independent variable. So what you do is you type in 1998, enter. 1999, enter. 2000, enter. 2001, 2002, 2003, 2004, 2005, 2006, 2007. So again, making sure you can arrow up 7654321 9998, and then you arrow over to L2, again using the arrow on this part. That's how you navigate around that thing. Here you have 1288, and this is where you have to be careful. 1304, 1322, 1344, 1366, 1378, 1418, 1421, 1443, and 1478. And again, what you want to do now is make sure everything matches in your calculator, otherwise things are going to go wrong. Once your list is there, now we want to go back to edit, so that's where we hit stat again, based off of your notes. I hope you're reading and following. If you look at the top part of this, you have edit, calculate, and test. Again, we want to calculate something because we actually want to find the linear regression or the line of best fit. So you arrow over to calculate. Please make sure your calculator shows that. And again, we are looking for the linear regression. And again, this here would be one variable stats. In case you want to know, that's where you find mean, median, mode, and stuff like that. Two variable stats is a little different. But what we're looking for here is the linear regression, so we hit enter here. And what that does is your calculator is saying, do you want to find a linear regression for ax plus b? If your answer is yes, you hit enter again, and you notice that it gives us an a and a b. We are going to cut those off at 2 digits behind the decimal point. So what you should see in your calculator is that a equals 20.68. Again, you have to approximate correctly, otherwise the computer is going to mark you wrong. And that b is negative 40,033.07. And so when it wants the equation for the line of best fit, it's like your y equals mx plus b, except it's ax plus b, so it's y equals 20.68x minus 40033.07. This is the first part of what you have to do today. Looks very complex, but again, the only thing you have to know how to do is go through the process to find a and b. You simply put a for your m, b for your b. That's your equation. Now the question is, how many tickets should be sold in 2015? Remember, we don't really know what's going to be sold in 2015, but that is your year. Keep in mind your year represented x, so all we have to do now is take and plug in x. So 20.68 times 2015 minus all this stuff here, and that will tell us our answer. So carefully typing that in, 20.68 parentheses 2015. Again, hopefully you're doing this for yourself, because if you don't know how to do it, it is not my fault. 0.07, and you get 1637.13. Usually once you're around, it's the nearest whole number, so 1637 should be the number. And if you look at the chart, based off of what's happening, it goes 1200, 1300 for a while, 1400, climbing slowly. So in about 8 years from there, it says it'll be around 16, so somewhere around there it should still be jumping up and going in that part. So again, if you had any issue with any of that, bring your calculator back, have me discuss with you what's going on. We're going to look at one more before moving on to your Math Excel. Again, do not try to rush through this, because if you don't know how to do it, there's no way you're going to be able to do this. This is a calculator based test tomorrow, and you want to know how to do this. Again, what we want to do now, because we want to find the equation for a line of best fit, we hit stat, edit. Notice that there's stuff here, so again we hit stat. I'm sorry, not stat. We go to memory, which is second plus, and again reset 7, all RAM 1, reset 2. So pretty much memory 712 clears everything. We go back to our list, or you could just type over everything, but I think that would get kind of complex. Here we have 1998 all the way up to 2007, 99, 2000. Make sure there's nothing funny going on. So 1998 to 2007. And from there, again, you arrow over to your second part and you type these numbers in. So 1280, 1295, 1311, 1346, 1366, 1390, 1404, 1417, 1438, 1470. Now, I will admit that knowing me, I might have made a mistake somewhere. I hope I have not, but if the numbers are different, it might be me, it might be you. The general idea for this is that if you are not careful typing in all these numbers exactly the way they are, it's going to throw off your line of best fit, and so your number will be off just a little bit. So just be careful whenever you're doing this that you take your time and do not try to rush through it. Other than that, once we get those numbers going through there, remember again we want to calculate it, so we hit stat, move over to calculate, and we want the linear regression. We select that part. This asks, do you want the linear regression of ax plus b? Yes, we do. It gives us a new value for a and b, which is that a is equal to 20.84. Again, make sure you round appropriately. And b is negative 40,365.25. That gives us the formula 20.84x minus 40,365.25. Again, that is your line of best fit. Again, this time they want to know based off of this, it's not going to be tickets, it's going to be alligators. And so how many alligators are going to be around, or whatever this would be talking about, really doesn't matter, because again, you just follow the process in 2015. So again, what we do is we take y, or we don't even have to do that part, 20.84, 2015 goes in, and that goes there. Again, take your calculator, plug it in, 20.84 times 2015 minus 40,365.25. Every decimal, every part is important. And notice again, when you cut it off here, you get about 1627, which is the second answer. That's how many alligators should be around in 2015. So again, what you want to do now is go to MathXL and begin working on the assignment. I know this is a long video, but pretty much you're working on two things. The first thing is you're making a scatter plot. The second thing is you're using the scatter plot in your calculator to determine the line of best fit and use it. It's a very basic assignment, and again, you need to make sure you get the most out of it. Kind of like a couple days ago where I said you should have got 100% on the assignment. You should have 100% on this assignment as well. And again, getting anything less just kind of tells me that you're really not as serious about it as you should be, because if you're not asking me questions and you're not finishing, something is wrong. Other than that, good luck. Again, tomorrow's assessment is a lot of calculator, and you need to be ready for it. So again, I hope you do what you need to do. I am, again, crossing my fingers for you. Good luck.